Hello everybody! Welcome to your 3-2 lesson on linear functions. Our learning target today, we're going to be able to identify, evaluate, graph, and write linear equations. We will be able to write and evaluate linear functions using function notation. We love that. We will be able to graph a linear function and relate the domain of a function to its graph. Sounds good. And we will interpret functions represented by graphs, tables, verbal descriptions, and function notation in terms of a context. So there's our word problems right there when we put context to the math that we're learning. All right, let's get a couple definitions into our notes. The first one is a linear function. So a linear function is a function. We learned about functions in our last lesson. That's where every input has exactly one output. It has a graph that is a straight line. So you guys have been graphing straight lines pretty much as long as you have learned how to graph. That's pretty much the only thing you know how to graph right now, I believe. So you have been graphing linear functions this whole time. You didn't even know. Linear functions can be written in the form y equals mx plus b. That's our slope-intercept form that we know, where m and b are constants. Constants just means it's a number that doesn't change, like your slope doesn't change, your y-intercept doesn't change. All right, now this function notation, I actually don't know if you guys have learned about this before. I guess you'll let me know. But function notation is a method for writing variables as a function of other variables. The variable y becomes a function of x, meaning the variable x is used to find the value of y. This is our notation for function notation, and it's read f of x. So when we see f parentheses with an x, we'll say, oh, f of x. It could be a different variable. You could have g of x or h of x. So the particular variable, the f, the g, the h is not super important, but that's what function notation looks like. And let's just make a note that you could have a linear function, y equals 2x plus 1. There's that slope-intercept form. You also could write it as f of x equals 2x plus 1. So what we notice is the y equals is the same thing as the f of x equals. So f of x essentially is the same thing as your y, but what they're saying is our function of x is 2 times that x plus 1. So f of x equals 2x plus 1. But let's not get too confused with it. There's no math to do. We don't try to divide by f or x. You'll see in some examples how we use this function notation.